Faraday-Starrett's law says that absorption is directly proportional to concentration. Another thing that's important is that the spectrometer must be calibrated against a blank solution, or water, so that measurements after it can use the blank solution's absorbance as a zero reference. Knowing all of this, the equation would be A equals ECL, A being absorbance, C concentration, L length of light path, and E molar absorption coefficient. After you've made your dilutions, you must transfer each one to a separate cuvette, being careful not to over or underfill it. You also will need to put your stock solution in a cuvette, as well as one with just water. When you're done transferring samples, you should have 5 cuvettes, 3 separate dilutions, a stock solution, and one with just water. Next, you must zero out the spectrophotometer before placing any cuvettes in the machine. Open the sliding door and wipe the sides of the cuvette that the machine will shoot light through to read. Close the spectrophotometer and click the Read button. Record your answer in your lab notebook, extract your sample, and close the sliding door. You must do all of this for every cuvette you have. After completing all 5 cuvettes, clean up your area. After getting the data for the other samples, we must also determine the concentration of an unknown copper solution. Repeat the same steps as before when using the spectrophotometer for the unknown.
After you go to the spectrophotometer and you measure your samples, your quantitative data that you'll get from your graph is your absorption value after you scan it. But your qualitative data is going to be the picture of the graph after you've scanned across all wavelengths. And the reason that you scan across all wavelengths is so that, number one, you can determine the best peak of your absorption value. And the second is that since light is absorbed at different intervals through each sample, it's really hard to get your best peak if you only scan one wavelength. And your lambda max is your maximum peak of absorption in each of your samples. And that's another reason of why you scan across all wavelengths, to try to find your lambda max.
Our unknown ended up having a 0.458 absorbance. Thank you so much for sticking around and watching our video. Until next time, bye!